So now we're going to start talking about data within R. So the first thing I want to do is review the general structure of data. So let's talk about that directly. Traditional data is organized in rows and columns, just like you see in Excel when you open a data set. A row represents an observation, so all characteristics related to the same thing. If you have students in your data set, one row is one student. If you have days of data, one row is one day. The columns represent the variables that were observed, or those characteristics that we've understood. So if you have a data set of students, it might be the grade on test 1, the grade on test 2 are each in their own column. And if you had days in your data set, you might have characteristics associated with those days. So how many hours were worked on that day, or what the weather was like on that day, might be in different columns. So here's an example data set. Each row represents one day in the year 2013. The reason we know that the year is 2013 is because we see a year variable that represents the characteristic of each of these days. We see year, we see weekend, which is an indicator of whether this particular day in 2013 is a weekend. If it's a 0, if it's not, it's a 1 if it is. We see an indicator of holiday. It's a 0 if that day is not a holiday. We see a 1 if it is. This is a measure of packages delivered on that day. So 11,123,479 on that first day. The next column is expected packages delivered. So packages delivered being what was actually executed, and expected packages being everything that was planned to be delivered on that day. And last, we see drivers working. This is an excerpt from a data set that we'll actually work with, but I just want you to see how data is traditionally organized. Now, when we refer to big data, it might be organized in other ways, but this is a very traditional representation of a data set where the rows are different observations and the columns represent variables observed on that particular character, the particular observation. So now that we've covered what does data look like, we're going to talk about what data looks like in R. So I'm going to open up R, and I'm going to open up my test file that I've been creating over the past few videos. And I'm going to make a new section called Matrices and Data Frames. So we have this concept of a matrix that stores numbers, lots of numbers, or it could store lots of characters, but it can't store lots of different things. So if you think about a data set where I have each of your grades, I'm going to want your names in there. I'm going to want your grades on different exams in there. And so I'm going to have words and I'm going to have numbers. In R, a matrix can only hold things of the same type. So it can hold all numbers or it can hold all words, but it can't hold words and numbers. So a matrix is not a good way to store each of your grades because I can't put your names in it and your test grades. I could only put your names or your test grades. So we introduced this idea of a data frame in R. A data frame is something that can store varying types of information, which would be perfect for a data set because it could store names, it could store numbers, it could store all kinds of things. So let's introduce how to create a data frame. So first, let's create two variables. One I'm going to call ticker. It's going to be a list of stock tickers. So I've got IBM, I've got Tiffany, I've got Cisco, and I've got MS, Morgan Stanley, in that list. So let me send that to the engine. And if I want to look at what ticker looks like, it's this list of stock tickers. Then I'm going to put a list of prices in a variable called price. And those prices are going to be 160.07, 91.99, 28.21, and 39.25. These are the values of the closing price for each of these stocks corresponding in order, of course. So on the day that I looked, IBM closed that day at 160.07. Tiffany closed that day at 91.99. So these are prices that people could buy Tiffany stock, for example. So now that I've sent price over here, look, I have two lists, one of words and one of numbers. I cannot store them together in a matrix But a matrix and a data frame are basically the same, except that I'm allowed to store in a data frame numbers and words. So let me create a data frame that holds both of these things together. So let's call it P, just doesn't matter. I'm going to say P equals data dot frame. That's a function that will merge two things together into the same storage unit, the data frame P. So I'm going to list ticker and price next to each other. These are two lists of variables. And let's look at what P looks like. You'll notice in P I have a column name, ticker, and a column name, price. It stores the tickers next to the prices. So IBM corresponds with its price, Tiffany corresponds with its price, Cisco corresponds with its price. So the nice thing about this is that I can look at the first row of P, P1 comma, and I'll know I'm observing, as we talked about the organization of data, this row is all the characteristics of a stock because I have data set containing different stocks. So the ticker for this stock is IBM. The price for this stock was 160.07. In row 2, I observe another stock, Tiffany. Its price is 91.99. So everything in row 2 corresponds to Tiffany stock. Everything in row 1 corresponds to IBM stock. So now, one thing that I want you to learn about data frames is that I can refer to the first column, which will give me all of the tickers. I can refer to it in the traditional way, which is P brackets, comma 1. That says, give me the first column. And it's giving me the list of tickers, but since this is a character variable, it's also telling me what are the possible values of that character variable. So Cisco, IBM, MS, TIFF, those are just the in-order values. So that means nothing. You can just ignore it. It's happening because that's a character variable. Now, another way I can refer to that column, the first column, is to do P dollar ticker. Now, remember up here inside of P, I had a column name of ticker. Even though I never said call this ticker, it's because it came from the variable ticker. When I created this data frame, I said use ticker and price. So it said, hey, that first column is called ticker. So now I can refer to ticker. Instead of saying use the first column, I can say use P dollar ticker. So that dollar sign is a reference. Use the column ticker inside of P. P holds all this data. It holds tickers. It holds price. Okay? So I could also refer to P dollar price, and it'll give me the list of prices. So if I wanted to do something with that column, I can just refer to it by name because it has a name since we created names for them in the data frame. Now, that's the end of understanding how we create a data frame and what a data frame might look like. We're not always going to create them manually because we wouldn't want to input data manually. We're going to use large data sets. So the next lesson is going to cover how to create a data frame by importing data from a source. So I'm going to save my code file in testfile.r, and I'm going to close this. Remember, when I close, it's going to forget everything I've told it before, and I'll have to recreate when I'm ready.